Hi class, here's the last video lesson for chapter 18. It's 18.3. What we're going to be doing in this lesson is finding all the roots of a certain polynomial function, which are the factors and the zeros as well. First, let's define what the factor theorem is the binomial x minus a is a factor of the polynomial f of x if and only if f of a equals 0. So what that is saying, class, is like when we factor something, we get like x minus 3. There's the factor. So what is the 0? The 0 is x equals a positive 3, right? Because x minus 3 equals 0, that means x equals the positive 3. So basically, this is the 0, or this is the solution, okay? And this right here is the factor. That's what this one is saying. They're, in a sense, a very similar thing in a polynomial function. This one is called the factor, and this one is called the 0. Okay? Or another word for the 0 is the root. Okay? So, what we're going to be doing in this lesson is we're going to be finding all of the zeros of a rational function. And so, this should actually say polynomial function. All the zeros of a polynomial function. So we have a polynomial function, and it might look like this. Okay? So what we have is we have 1, 2, 3 zeros. We're going to find exactly where they are at. This might be at a negative 3, a positive 1/2, and a positive, 1, 2, 3, 4, 4.5, or something like that. We're going to be finding all of those. We're going to use these steps. We're first going to find all the possible factors. We're going to use the rational zero theorem. We did that in yesterday's video lesson. And then we're going to plug in factors until you get one that equals 0. What we're going to do here is basically just substitute a factor in there. And then we're going to use that factor to long divide. We did that two video lessons ago, long division. And then we're going to factor that depressed polynomial or use the quadratic formula. So these are the 4 steps that we're going to take on every single one of these problems for today. So let's just go through it step by step. We want to find all the zeros of this one. So I know that there are going to be 3 zeros because my degree is 3. So let's just first list all the possible factors. Let's list all the possibilities using the rational zero theorem. So I know that it's going to be P over Q, which is factors of 2 are 1 and 2, and factors of 6 are 1, 2, 3, and 6. So let's list all the possible factors, okay, or all the possible zeros that would satisfy this equation. So what I'm going to do is it's going to be P, all these over Q. So let's put them over 1. So it's plus and minus 1 divided by 1, which is 1, and plus and minus 2 over 1, which is 2. Now we're going to put 1 and 2 over 2. So then we're going to get plus and minus 1/2, and plus and minus 2 divided by 2, which is just 1. I don't have to write that again. Other possibilities are 1 and 2 divided by 3. So we got plus and minus 1/3, and we have plus and minus 2/3. And then we're going to have 1 and 2 over 6, so plus and minus 1/6, and plus and minus 2/6. And 2/6 is the same thing as 1/3. So class, we have successfully listed all of our possibilities. Okay? Now, this is a step that every student hates. Okay? Letter B is not fun. What we want to do is we want to plug in numbers until we get one that equals 0. So we have a whole bunch of them. We have 2, 4, 6, 8, 10, 12 numbers. We have one of these 12 is going to make this be a 0. Okay? So we need to find what it is. So what I always just say is start with our integers. Fractions get kind of messy. So let's just start with this positive 1. Okay? I'm going to put a positive 1 in to this. So instead of h of x, I'm going to say it's going to be h of 1. I'm going to put 1 in for every x. So I'm going to have 6 multiplied by 1 cubed plus 11 times 1 squared minus 3 times 1 minus 2. So what I'm doing here, class, is I want to find a 0. I know that one of these is going to give my polynomial function a 0. So I'm just guessing on which one it's going to be. So if you're asking me, Mr. Berge, why did you start with 1? It's just because we have to start with something, okay? You can try, if you want to start with 2, or if you want to try with 1/6, or whatever the case might be, you can try any of those. I'm just starting, let's try with 1 first. So now we have 1 cubed times 6 is 6. 1 squared is 1 times 11 is 11. And now we have minus 3 times 1, so we get a minus 3 minus 2. Well, this becomes 17, minus 3 is 14, minus 2 is 12. Oh, we didn't get ourselves a 0. So evidently, positive 1, you are not the right thing. So now, class, we know that that did not give us a 0. So now, let's try a different number. We know that this one right here is out. So now let's try the negative 1. Maybe that'll work. So a negative 1 goes into h. So x times a negative 1 raised to the 3rd power plus 11 times a negative 1 squared minus 3 times a negative 1 minus 2. Let's see where this gets us. A negative 1 cubed is a negative 1, and a negative 1 times 6 is a negative 6. A negative 1 squared is a positive 1. 1 times 11 is a positive 11. 3 times a negative 1 is a positive 3, and then minus 2. So this would give us 5. 5 plus 3 is 8. 8 minus 2 is 6. Rats! That didn't work either. So I know that plus and minus 1 did not work. So let's go on to the next one. Let's try 2. We're going to keep on doing this until we get a 0. And class, I promise you, eventually you will. Don't ever think, this is dumb, I'm never going to get it. Eventually you will. So now let's try h of 2. Let's try h of 2. So it's going to be 6 times x cubed, so it's 6 times 2 cubed, plus 11 times 2 squared, minus 3 times 2, and then subtract 2. Here we go. 2 cubed is 8. 8 times 6 is 48. Plus 2 squared is 4, and 4 times 11 is 44. Well, you could already kind of see right here, this isn't going to equal a 0 either. This is getting frustrating. Keep on going, class. Keep on going. Let's not lose heart. We're going to keep on keeping on, and we're now going to put in a negative 2. Okay, we're going to keep on trying these until finally we get one that equals 0. So let's try a negative 2. So it's 6 times a negative 2 cubed, plus 11 times a negative 2 squared, minus 3 times a negative 2, minus 2. Here we go. A negative 2 cubed is a negative 8. A negative 8 times 6 is a negative 48. We have a negative 2 squared, which is a positive 4. 4 times 11 is a positive 44. We have a negative 3 times a negative 2, which is a positive 6, minus 2. So here gives us a negative 4 plus 6. A negative 4 plus 6 is a positive 2. Minus 2. Ah! Yes! We got it. H of a negative 2 equals 0. That's exciting stuff, right? Good. We got our 0. This is good news. Step B is done, and step B is the most dreadful step. Okay? So now what we're going to say, class, is we're going to use that factor to long divide. So we said that x equals a negative 2. Okay? So that's, when we put a negative 2 in for x, it gives us a 0. So that means this is the 0, so use the factor. The factor means I'm going to add it to get a 0 on the right side. So x plus 2 equals the 0. So what's the factor? It's the positive 2. I hope that makes sense to everybody. Once again, this is the 0 or the solution or the root. This right here is the factor. And we need to use the factor to long divide. Okay? So we're going to use the factor of x plus 2. So x plus 2 is the factor. So let's use that to long divide. X plus 2 goes into our dividend, which is 6x cubed. 6x cubed plus 11x squared. And then we got minus 3x minus 2. Now, class, here's a great check as you're doing this one on your test. When you're doing this one, when you get to this step, a negative 2 equals a 0. So that means my remainder shouldn't happen. You shouldn't get a remainder. Your remainder should be 0. So that's a good check as far as whether or not you're doing this right. So let's long divide. X times what gives 6x cubed, and that is 6x squared. Let's bring it down. 6x squared times x is 6x cubed. 6x squared times a positive 2 is a positive 12x squared. Now we're going to subtract both of them. This cancels, and we get a negative x squared. Bring down the negative 3x, and we have ourselves x times what gives a negative x squared? A negative x. So a negative x times x is a negative x squared, and a negative x times a positive 2 is a negative 2x. Let's do the opposite, so add here, add here. Now this cancels out, and we just get a negative x. Bring down this negative 2. So now we ask ourselves the question, x times what gives a negative x, and that is a negative 1. Because a negative 1, multiplying back down, a negative 1 times x is a negative x, and a negative 1 times a positive 2 is a negative 2. So now we're going to do the opposite. So add here, add here. This cancels out, and a negative 2 plus 2 is 0. In class, once again, this should always, 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 always happen. Okay? Once you find a factor that equals 0 in step B, when you long divide, you should get a remainder of 0 in step C. Always remainder 0. So if you don't get that, you've done something wrong, and then you can check your work. So now, finally, letter D. It says factor the depressed polynomial or use the quadratic formula. So the depressed polynomial class is your quotient. It's this one right here. So this is going to give you the other two solutions. So x squared minus 6x squared minus x minus 1. 6x squared, what did I say? Minus x minus 1. We can use the quadratic formula here, or we can factor. I believe this one can be factored. So if we do 3x times 2x, we'll get ourselves a 6x squared. And then if we do a negative 1 here and a positive 1 here, I believe that works. So the first is 6x squared minus 3x plus 2x is a negative x, and a positive 1 times negative 1 is a negative 1. So now these, class, are our other factors. So what are the zeros of this function then? What is our final answer? Okay, 3x plus 1 equals 0. That means x equals a negative 1/3. And then we have 2x minus 1 equals 0. That means x equals a positive half. And then our final one is the one that we found with long division. X plus 2 equals 0, which means x equals a negative 2. So we also have the x equals a negative 2. Whew! There are 3 zeros because the degree is 3. So here we have it right here. The degree is 3. What are the zeros? Here's the possibilities. As you can see, class, we found on step B, by substituting, that a negative 2 was one of the zeros. If you would have put in a negative 1/3, or if you would have put in a positive 1/2, you also would have got a 0 in step letter B. So you can, there's more possibilities than just that negative 2. So that's going to be the answer. Now, you guys use the work that we did on problem number 1, and I want you guys to do the exact same thing on problem number 2, okay? Go through each one of those steps, try it as best as you can on your own. This is really good practice for you. So pause the video, try it on your own. After you tried number 2 on your own, letter A, we're going to list all the possibilities, which is 1 for factors of Q, and then factors of P are 1, 2, 3, 4, 6, and 12. So as far as listing all the possibilities are concerned, it's just going to be plus and minus all of this divided by 1. So it's plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 12. Alright, on step B, hopefully you tried a bunch of them until you got one that equals 0. As you did this, I got the one for positive 2. So I found out that when h is 2, I got myself a 0. So let's work on that here. that equals x cubed, which is now 2 cubed. Oh, minus, sorry about that. Minus x squared, so it's minus 2 squared. Minus 8 times 2 plus 12. So when I got this, I had 8. 2 squared is 4, so a negative 1 times 4 is a negative 4. And then I got a minus 16, and then a plus 12. And then as you can see, right here, 8 and 12 make 20. A negative 4 and negative 6 make a negative 20. So h of 2 gives me a 0. So if x equals 2, that means x minus 2 is going to be the factor. So for step letter C, we have to use this factor to long divide. So x minus 2 goes into my polynomial, which is x cubed minus x squared. And then minus 8x plus 12. Okay, so now we're going to long divide this. So we get x times what is x cubed? X squared. Multiply it down. X cubed minus 2x squared. Take the opposite. Change the signs on both of them so we get a positive x squared. Bring down the negative 8x. X times what is x squared? X times a positive x is x squared. So now multiply it down. X times x is x squared. And x times the negative 2 is a negative 2x. So now we get a negative, oopsie, change the signs on both of them. So we get a negative 6x. And then bring down the 12. X times what is a negative 6x? A negative 6. Multiply a negative 6 times x is a negative 6x. A negative 6 times a negative 2 is a positive 12. Take the opposite, add, subtract, and we get a remainder of 0. Once again, this should always happen if you do it correctly. You should always get that remainder of 0. So now we're going to factor the depressed polynomial to finally get our roots. So we have x squared plus 6x minus 6 is our quotient. X squared plus an x minus 6. Yes. So let's factor this sucker. X multiplied by x and a positive 3 with a negative 2. So if x plus 3 is a factor, it equals 0. That means my solution, x equals a negative 3. There's one of my answers. X minus 2 equals 0. That means x equals a positive 2. There's another one of my answers, and then the other one was this one in step B. We found it by substituting, which is x equals 2. So we have x equals 2 twice here, don't we? What does that mean when we get x equals a number 2 times? We call that a double root. So we have 3 answers, because our degree was 3, right here. X cubed is our degree. So with that, we know we should get 3 answers, and there they are. X equals a negative 3, x equals a positive 2 twice for our double root. All right, last one. We're going to do this exact same process one more time. Number 3 is slightly more difficult, and the reason why is because the depressed polynomial cannot be factored. So let's work this one through, and I'll show you how that works. Factors of Q are just 1. Factors of P are 1, 3, 5, and 15. So when we list all the possible rational zeros, it is plus and minus 1, plus and minus 3, plus and minus 5, plus and minus 15. Now at step letter B, this is where we try like a positive 1, and then a negative 1, positive 3, negative 3. Keep on trying them until you get a 0. I'll just tell you what it is. The first one we can get is 3. So if we do, what's our letter here? H. If we do h of 3, that is what is going to give us a 0. In class, I just told you that. If you're doing this on a test, you're first going to try the positive 1, and then you're going to try the negative 1, and then you're going to try the positive 3, and bam, you're going to get it. But being that I've done this before, I'll just tell you what the answer is. We can do 3. So it's 3 cubed minus 7 times 3 squared plus 17 times 3 minus 15. So let's continue simplifying now. 3 cubed is 27. Minus 3 squared is 9. And 9 times negative 7 is a negative 63. 17 times 3 is 51. And then subtract 15. So now when you do this, 27 minus 63 plus 51 minus 15, you get a 0. So h of 3 equals 0. That means h equals 3, or sorry, x equals 3. X equals 3. That means that the factor is x minus 3. So we're going to use the factor to long divide. So x minus 3 is going to go into our polynomial, which is x cubed minus 7x squared, and then plus 17x minus 15. And now we're going to long divide. So x times what is x cubed? X squared. Multiply it down. X cubed minus 3x squared. Take the opposite or change the signs on both of them. Cancels out. Negative 4x squared. Bring down the 17x. Let's do the same thing. We're going to have a negative 4x up here now. Multiply it down. We have a negative 4x squared plus 12x's. Change the signs on both of them. Cancels out. 5x. Bring down the negative 15. X times a positive 5 is going to be 5x. And then 5 times a negative 3 is a negative 15. Change the signs, and we get a remainder of zeros. This should always happen. So there's our check along the way. So we're going to now factor our depressed polynomial or use the quadratic formula. So x squared minus 4x plus 5. X squared minus 4x plus 5. So class, at this point on your test when you take it, you're probably going to go like this, and you're going to try several different possibilities. What happens when I have a positive 5 and a positive 1? Or what happens when I get a negative 5 and a negative 1? And see how all those possibilities work. And then you're going to try until you're blue in the face. You'll say, this one can't be factored. So if it cannot be factored, that's when you use the quadratic formula. If you haven't memorized it yet, hopefully you will soon. Okay, it's a negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So we have one of the factors. One of those factors is x equals 3. There's a total of 3 factors because our degree is 3. So we need 2 more factors, and the 2 more are found by using the quadratic formula right there. So we're going to have a negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Simplifying this, right here we get a negative 20. So a negative 16 minus 20 is a negative 4. So 4 plus or minus the square root of a negative 4 all over 2. Continuing to simplify, this right here becomes 2i. So 4 plus and minus 2i divided by 2. We can take out a greatest common factor, or we can reduce all of these coefficients. You can take a 2 out of. So we have 2 plus or minus 1i, or 2 plus or minus I over 1. So we have 3 factors. Sorry, we have 3 zeros, or roots. Those are x equals 3, which we found up top. X equals 3. And then our other 2 are x equals 2 plus an I, and the other one is x equals 2 minus an I. 3 answers, and there they are right there. So our last assignment here for Chapter 18, you're going to get a worksheet on 18.3, which does this exact same stuff. Be sure to let me know if you have any questions when you get this worksheet tomorrow.